In this video, we are going to be looking at NECO possible physics practical for 2024. Okay, based on the materials that they ask schools to provide, the closest that we can have is something like this. Okay, so we're going to follow the instructions, but schools were not asked to provide an ammeter, rather a voltmeter. So it therefore means that there are three possible physics practical that you can engage with in this year's NECO. And I have prepared for those three practicals, these three possible practicals that we can get. So what we're going to do is to use the instructions here, but instead of recording the current, we record voltage, because we are not asked to provide ammeter, just a voltmeter. And mind you, in this video, I'll just show you how to get the readings. I'm not plotting the graph because this practical that involves this kind of material has not been carried out anywhere before. So I would not know what should be plotted against the other elements. So what we'll do is just carry out the readings, make the setup, carry out the readings, and see what our results are going to look like. So we'll follow the instructions here, then I'll create a table. Then instead of using an ammeter or recording the current, record the voltmeter like I said earlier. So let's quickly read through this. So I'm going to alter some of the right up here. I'm going to alter some of them to fit into a voltmeter. So let's read through. You are provided with a Constantine wire, a 2 ohm standard resistor, an accumulator E, an ammeter. No, instead of an ammeter now, I'm going to change it to a voltmeter. So an accumulator E, mind you, NECO provided, asked school to provide either an accumulator of 2 volts or a combined 1.5 volt times 2, that's 3 volts 𝗘𝗟𝗘𝗖𝗍𝗔 cells. Okay, so instead of an ammeter, we have a voltmeter, a key, and other necessary apparatus. So I'll show you how the circuit is going to look like. I've already drawn that out, so I'll show you how the possible circuit could look like. So measure and record the EMF of the accumulator provided or the dry cells provided. So you're going to measure this. We're going to measure that from the beginning. Okay, so I'll indicate that on my reading. Connect a circuit as shown in the diagram. Okay, the circuit is going to be a little bit like this, except with the ammeter and a voltmeter connected. So I'm going to show you the three possible way we can get that. Close the key, read and record the. Now instead of the ammeter reading, we're going to measure the voltmeter reading and call that V0. So we're going to record V0, okay, instead of I0, when the crocodile clip is not in contact with the wire, with the Constantine wire. Okay, open the key with the clip making contact with the wire. When L is 85 cm, close the key, read and record the, now not the ammeter reading now, the voltmeter reading, and evaluate L inverse. Repeat the procedure for L equals 35 cm, 65 cm, for 55 cm, and 45 cm. In each case, read and record the, so instead of the ammeter reading now, the voltmeter reading, and evaluate L inverse. Anyway, you may not be evaluating L inverse, but that's not the essence of this video. The essence of this video is to see how you can set up this circuit, whatever the circuit looks like, and also be able to determine the voltage. Tabulate your readings. Okay, you have to plot whatever against what. So I am not interested in that. What I'm just interested in is how to get this reading. And maybe some other video I can come up with some parameters that you can actually plot against other parameters. And I'll help you. I think I should do a video on that. I'm going to do a video on that and see how that looks like. Okay, so now let's look at the setup that resembles this that I've drawn out for us to see. So these are my possible setup. This is possible setup 1, and I've already drawn out the voltage for the table for length and the voltage. And this is my possible setup 2, and the table for length and voltage, and this is my possible set of 3 for the length and voltage. So this is what I'm going to do. For the first one, it looks exactly like the first circuit that we have there, meaning that the constant wire and the 2 ohm resistor are connected in parallel, and we have to determine the voltage of the parallel connection. So you see, this is the crocodile clip, and this is the constant wire, the key, and the cells or the accumulator. So this is the table for that. Then for the other one, so now you see that here the voltmeter is connected to the 2 ohm resistor, which is in turn connected to the constant wire in series. So you see they are both connected in series, but we have to determine the voltage across the 2 ohm resistor only. And finally, the third possibility is that the 2 ohm resistor and the constant wire are connected in series also, but this time around the voltmeter is connected in across the constant wire only. So these are the 3 possibilities that we can get. Now the next thing I have to do is to set up this. I'll set up this, then we'll carry out the 3 possible experiments. The setup is basically the same, just changing the voltmeter. Okay, so let's quickly get that done now. So this is my voltmeter. We're asked to provide for 5 volts, but I do not have that, unfortunately. So I have 2 volts and 5. We're asked to provide 3 volts. So since we don't have that, we're going to use the 5 volts for this experiment. So when recording the 5 volts, we're going to use the down part of this, because that's 5, and the top is 2 volts. So the top is 2 volts and the down part is 5 volts. So we're going to be using that because this just ends at 2 volts and 5 volts. So I don't have 5 volts for that. So we're going to determine E, the EMF of the cell. So this is my battery. So this is my battery. So this is the negative terminal, this bottom. So I'm going to connect this to this. Gently do this so that you don't destroy the terminals of this, because they are very fragile. So you connect this tightly to the negative part. Then you connect the positive to the 5 volts, because it's not up to 3. So I don't have 3 there. So I'm going to connect this. So you see, immediately I connect this and tighten this, you see the voltage. You will be able to read the voltage there. So I can just hold it if it's not reading. So from here, that's 3.1 volt, and I have a 0 error at this part. So this is my reading. So that's my reading, 3.5. That's 3.115 volts. It's 3.15 volts, but I have a 0 error here before, so I'm going to record that as 3 volts. I'm going to record that as 3.0 volts. Now, the reason why I was able to read a high value out of this is because this battery are still new battery. Okay, so again, now let me disconnect this. Then we'll now connect the circuit. So let's connect the circuit. So we're going to follow the circuit diagram. This is the positive terminal of this cell, and this is my positive terminal. It's connected to the constant wire, one end of the constant wire. This is my constant wire. You can see that it's long. So this end here, I'm going to connect it with this end and the voltmeter. You get this? So I'm going to connect this. Okay, this end, this is one end of the constant wire. That end is connected to the voltmeter and the other end connected to the resistor. So what I'm going to do, I'll take another wire. Okay, so I'm going to have 3 wires on this. The reason why I'm going to have 3 wires is because, okay, so I have 2 here. So look at this. This one will go to the resistor, and this one will go to the positive terminal of the voltmeter. Okay, so let me knot this together, and the end of the Constantine wire. So I'm going to tie this all three together. So I'm going to tie them together. So the three has been tied together. So I'm going to connect this, one of these, to the 2 ohm resistor. So this is the 2 ohm resistor here. So I'll connect this to this. Any of the wire can go to that place. Then this other one will go to the positive terminal. Remember, we are using the 5 volts. We are asked to provide 3 volts. I just hope I can get my readings of this. So I'll tighten this. Okay, so that's one part of the circuit. Then the other part, on the other side, the voltmeter goes to a crocodile clip. So this is my crocodile clip. So I'll just remove this. So this is my resistor. Now you see, then from this resistor, the other end will go to the negative terminal of this, as you can see from here, and the other end goes to the crocodile clip, while the final part goes to the key. Okay, so I'm going to get another wire. So I'll just open up the crocodile clip. So I'm going to open this up. Then I'll place this inside of this. Or you can just place it this way. Roll it up. And then close it with this. Okay, so I'm done with this. Then I'll connect another wire. Then at this terminal, so this is my crocodile clip connected to this. You can see it here. So I'll have another terminal. So these 2 terminals will be connected. In fact, I'm going to have 3 of these terminals also, because one of them will go back to the key. So I'm going to have another wire. Join all 3 of them together. So I have 3 wires. So one of them is for the crocodile clip. So this will terminate here. The end where the 3 meet will terminate here. So I'll terminate this here. Then one of these goes to the key. One of these will go to the key. Then the remaining one will go to the negative terminal of the voltmeter. So basically this is my connection. So you can see this. My Constantine wire, or just take it out of this. So the remaining part is to connect this to the key. So this is my key. So you see from here, one goes to the negative terminal of the battery. One is connected to the crocodile clip. And the remaining one goes to the key. So I'll connect this to the key. So finally, I'm going to connect the negative terminal of the cell to the key. Okay, so that's our complete connection. The connections could be a little bit clumsy because of the combination of wires. So again, let me take you through that. The positive terminal connected to this end. So the positive terminal of the cell connected to this end. This end has three junctions here. One to the standard 2 ohm standard resistor, one to the positive terminal of the voltmeter, and one to the Constantine wire. Then this has 3 terminals also, one to the key, one to the crocodile clip, and one to the negative terminal. So this is basically my connection. So okay, so the first thing they ask us to measure is V0. Okay, we have to measure V0. We have to measure V0 when it is not, the crocodile clip is not connected to the wire. So let's close the key and see what we have. So without the crocodile clip imputed there, so I have 1.80 volts. So that has been recorded as to this place, 1.80. But then next, we have to measure the length of the wire, then place the crocodile clip on it. So I'll get my meter rule. It's a bit clumsy because of the connection of the wire. You just need to get the right connection. Once you get the right connection, you can get every other thing. So I'll place this here. Just place it at the 0 mark. And I'm going to measure 85 cm. So 85. This is 85 cm here. So I have my measurement on 85 cm here. So this is on 85 cm. You can see it there. Okay. 85 here. So I'll just hold it and take my crocodile clip and clip it at that point. So I'm going to clip it. So I've clipped it so you can see this. Then close my circuit, close my switch rather, like okay. Then again I'll take my reading. So from here you can see I'm having 1.12345. So my voltmeter reading is 1.45 volts. So that's the reading here. The one you have your 1.45 volt. Next, I'm going to measure the next length is 75 cm. So I'm going to measure 75 cm. So I'm going to measure 75 cm and we'll take the reading again. So I'll remove the crocodile clip. I'll measure 75 cm. Okay. Use my clip and clip it at that point again. Basically, electricity practicals are usually very easy if you understand how to connect the section. So I'm going to close my switch again. Then we'll take the voltmeter reading. So what I'm having is 1.35. So I'm going to record that as 1.35. That's why it was required of 3 volt meter. So if we have a 3 volt meter, there will be a lot difference between the readings from the voltmeter. So let's get 65. I'm going to measure 65 now. So this is 65. So I'll take the crocodile clip and put it on this. Then again, we'll close the circuit and take the voltmeter reading. That's obviously 0.65. So that's 0.65. Then now I'll have to reduce the length to 55. Okay, so from here, I'll just remove 10, length of 10 from this. So that's going to give me 55. Just remove a length of 10 from this. So this is 10. So 0 to 10, I'm removing this 10. So that's how you reduce the length, instead of measuring the length all over again. So I'm going to put this. Then close my circuit again. Now I'm having 1.25. I think there's an anomaly with the second one, 1.25. I'll take that reading again. So from here, so once you have a difference in readings like you can just take it again. So I'm going to measure 10 from here again to take that 65 again. From here, I'm going to take it 10 to this point. That's 75. So I'll put my crocodile clip. So once there's a little, then close the circuit. That's 1.3. So that's 1.30. So I think I've corrected that now. 1.30. So that's corrected. 1.30. Then finally, I'm going to take 45. So from that place, I'll just remove 20 from that downward to make it 45. So I'll remove 20. So this is 45. So I'm going to close that again. Then close my circuit and let's get the voltmeter reading. That's 1.0. So that's 1.00. So these are my readings. So what you always have to look at are the trends on this. So you always have to look at the trends on all of this. So you see that this was, as this was decreasing, this was also what? The decreasing. Okay, so this is expected because the resistant wire and the resistors were connected in parallel. So as the length of the resistant wire decreases, then the combined resistance, the resistance of the resistant wire will also decrease, and hence the combined resistance will also what? Decrease. The voltage drop across the two of them then what? Decreases as the resistance what? Decreases. So let's look forward to the next connection. The next connection, what I will just have to do is just to remove the voltmeter from the connection between the two of them. Then I'll connect it back as one. So this is going to look like this. It's going to look like this. I'll just have to remove the resistant wire from this. Let me just pause this. Okay, now in this case, only the resistant wire is now connected to the positive terminal of the dry set, so you can see it. Then from here, we have one terminal of this connected to the crocodile clip. Now, only the resistor is now connected in parallel, you see it, across the voltmeter. Okay, then the other terminal is connected to still connected to the key, and the negative terminal, or the key connected to the negative terminal of the battery. It's going to be a little bit stressful because of the clumsy, because of the connections. But all we have to look at is how to get the readings from the voltmeter. So let's see this now. So I'm going to measure 85 cm on this, as usual, the same way. Then we'll start reducing it by 10 to get all others. So I'm going to measure 85. So from here you can see this is 85 cm. So I'm going to use my crocodile clip to clip this at this point, at the 85 cm that I've just measured. Okay, so you must ensure that the wire does not touch this other part does not touch this. So let's close the circuit and take our readings. So we have a voltage of 1.35. 1.35. That's my reading, 1.35. So let's see. So I'm having 1.20. So that's my voltmeter. Then I'll reduce it by 10 again. Voltmeter reading, I'll reduce it by 10. So I'll place this on this and put it here. So that's going to make it 65. So I'll just try for this, then I'll do the remaining other ones. So you can see the voltmeter reading there. That's 0.8. So 0.8. 0.80. So I'm going to reduce that by 10 again to make it 65. To make it 55 rather. So I'll reduce it by 10. So I'm going to put this on this. So you can see I am having 0.90. 0.90. So I have to take the other length back again because there's a little bit of, so I'm going to take 10 cm backward again. Here. Okay, I'm getting something, okay, 0.90. 0.90. So just my description, I make it 0.95 because it should be greater than, that's what the examiner wants to look at, 0.95, okay? Then I'll reduce this by, so I'm going to reduce it by 20 to get to 45 because that's 65. 20. So this is 55. So I'm going to close it. So I'm having 0.70. 0.70. So this is basically the practical for the second part. Now the third part, I'm going to, because of the length of the video, for the third part, you do the same arrangement, but this time around, you just place the voltmeter across this and this. And also, follow my videos for more on this, and I'll also show you on how to get manipulated results on this, and also follow my video. Check out for the other type of practicals that will be coming up for this. The one of first sport, watch out for that. And you can search through my collections of videos on YouTube to see the videos that I've done on refraction through triangular glass print. So I will not be doing that again. Just search through my video collections and you're going to see that. Do not forget to subscribe, like, and share your comments if you find this video very helpful for you. All right, see you in the comment section, and good luck as you write your physics NECO exam.